let's work on another problem for today. So our second problem of today is going to be rotting oranges. This is LeetCode number 994, given an m by n grid where each cell could have one of three values, 0 representing an empty cell, 1 representing a fresh orange, and 2 representing a rotten orange. Every minute, any fresh orange that is 4 diagonally adjacent to a rotten orange becomes rotten. Return the minimum number of minutes that must elapse until no cell has a fresh orange. If this is impossible, return -1. So, I think what I'm going to do for this, the first thing that came to mind is something similar to 0, 1 matrix, O1 matrix. And the idea is that we could perform BFS because that will be the how do I describe this? This will be the fastest because there is no weight between each cell, so the minimum amount of time for an orange to rot is going to be the closest rotting orange. Let's see. Let me think about this a little bit more. So if this is 0, these will have a value of 1. These will have a value of 2. This will have a value of 3, and then 4. So something similar to O1 matrix, but they can start off as something similar as to O1 matrix, but of course the values could be different, very much different. On each rotting orange, we'll need to copy the matrix in some way and probably mark the oranges in a specific manner such that we really care about the state of the orange in a different way. So a rotting orange, I think rotting orange will have a value of 0. A fresh orange, let's see, what is the maximum in orange? So if m and n are at most 10, then a fresh orange could at most be, let's see, 1, 2, 3, 4, 5, 6. I think something like a 21. Honestly, I could just do like 100 here for a fresh orange. I know that 100 is a safe value for an m by n of 10. So, let's see. And then empty cell can be -1 or something, right? If there's because there's no value within those. So we will mark the oranges in a specific manner, then iterate over the array, performing BFS at each rotting orange initially. And we'd be doing something very similar to O1 matrix if the value of a cell is greater than the value that we want to override it with, then do so and add its neighbors. Basically, we want to proliferate the decrease in time if it exists. And then here's maybe the part that I'm not too happy with, but basically iterates over the matrix one last time, collecting the maximum value. If it happens to be 100, return -1 instead. Because if the maximum value is 100, that means that there is an orange that after all the proliferations has not rotted, and therefore we can just return -1 right then and there. So let's see. In terms of runtime, this will be big O of m times n to copy the array, O of m times n for BFS on the array, and O of m times n again for finding the max, right? So in total, this will still be O of m times n. I don't think the BFS, I don't, Is it possible for an array I think it is possible if we have a rotting orange on each corner and then just oranges all the way down. We could have the BFS iterating over the entire array. So I think the true runtime might be O of m times n times r, where m, n are the dimensions of the array. R is the number of rotting oranges. Because we could run BFS essentially on each of the rotting oranges, right? And of course, our space complexity, let's not forget about that this time, is O of m times n, I believe. Let's see. I'm really iffy on this and like even the last problem with number of islands in terms of the space or time complexity. Space complexity is pretty straightforward, but time complexity is a little bit tricky. Like at least in number of islands, we know that if we flood fill like an entire space, then we know for sure that we will still iterate through them, but we will not perform BFS on any of the remaining cells. However, in this one, we basically do have to perform BFS on each rotting orange to make sure, and there could be a situation where the BFS could run through a decent chunk of the array, right? Or the decent chunk of the matrix. So I'm really not sure on this one. But in any case, I think this is a decent solution for now. I think the main thing that I'm not happy about, like I said, is this last iteration over the matrix. There might be a way to handle that. We'll see. So let's get started. We'll say val rot matrix is equal to a mutable list of integer values. This will be of grid size initially, and then we'll create a mutable list of integers in here, where it is the grid at index.size. And this will be initialized in accordance to our algorithm. So if grid at index, we can call this column, right? Like we did before. And we can call this one row. is 0, then our grid at column, or not our grid, then, well, we want to return -1. Else, if grid at column row is a fresh orange, then we want to return 100. Otherwise, we can return 0 for the number of seconds until. So these numbers essentially represent the number of minutes until the cell is rotten. So now we can say rot matrix for each indexed column row list for each indexed row value. Fun BFS placement centered at a column integer, a row integer. So this will be our BFS with placement. If rot matrix is 0, well, we don't want to do grid at column row. If we did our rot matrix check for our rotting oranges, then we would call the BFS with replace on a lot of values as they get replaced. So we should not do that. Need our data class cell again with a val column int and a val row int, and then while q is not empty, val front is q first, and then q remove at 0, and then let's see, we basically check if we want to check our 4 cardinal directions, right? So if column -1 is greater than or equal to 0, and we need to provide a reference to our array or a matrix, which will be a mutable list int if, let's see, front column front row, because we want to always be comparing what is on our queue, is less than or equal to our front, let's see, our matrix at front.column, front.row. So our current value plus 1. Then we do that. If our column is going to be less than our size, and likewise for our row, plus 1 is less than our matrix at front.column.size. Minus 1 here. Basically, we're just doing our 4-dimensional. We're doing basically our O1 matrix here again. And we're just comparing that against our own. Then we want to do our matrix at cell, or at column minus 1 row is equal to matrix at front column front row, our current value plus 1. And then our Q, add a cell that represents that column minus 1 and a row. Basically, we can do the same thing for each of these. Honestly, should have copied and pasted after I finished completely filling out the first to make it a little bit easier on myself. That's fine. You need a minus 1 here. You need a plus 1 here. Get rid of you. And a plus 1 here. So this is our first iteration through. Then we can say our var max. We'll start off by saying 0. And then our rot matrix for each column row list. Actually, we don't need this index, I don't think. Row list dot for each value. If value is greater than max, max is equal to value. Basically, we want to find the maximum. Well, actually, if value is equal to 100, return -1. Right? That basically means that if we still find a fresh orange at that point, then we just return -1 because not all the oranges will be rotten ever. The max is 0. Oh, of course, we also want to say, and the value is not... Well, actually, it's a maximum, right? And of course, 0 is always going to be greater than the empty cells, which are -1. So we don't need to do any of the additional checks there. So again, like we said, we initialize this matrix copy, essentially, where empty cells are -1 minutes. Currently, fresh oranges have 100 minutes, and already rotten oranges have 0 minutes. We go through and we do a BFS if the grid is 2. So if we had an orange that started off as rotten, we want to do BFS with replacement at those points only. So we check the original grid for that value. Then we do BFS with replacement on that column row, and then we can toss in our rot matrix, and hopefully Kotlin does this as a pass by reference and not pass by value, because I need this to be a pass by reference. It should be, I assume. So this does BFS with replacement. So this creates a new queue for each BFS call. While the queue is not empty, we will churn through it and we check. So the top one, if we go up one on the column side, so we go left, and the value is the current value that it holds, which starts off as 100, is less than or equal to our current value, which should be 0 plus 1. Then we set it, and then we add to it. We add it to our queue, and we propagate it against the other cells that are neighbors to it in the 4 directions, right? Same thing with the right. So matrix.size this time, and then we do the similar comparison here. And then if if the condition holds, then we set it, and then we add it to our queue. Same thing with our row, greater than or equal to 0, and then we compare this would be up 1 row towards 0, so that'd be up. We reset it, same thing, and then down we do the same thing, and then we basically continue from there until we've exhausted all options, basically, to sort of propagate our rotting matrix, our O1 matrix sort of deal. And then finally, we start off with the max of 0, and then we iterate over. If we see that there is still a fresh orange at the end, we return -1, because we've gone through all the values and we've propagated all the rotting. So if there is still a fresh orange, we return -1. The number of minutes that will take for all the oranges to rot is, well, non-existent, because the oranges will never fully rot. Otherwise, if we find a new maximum, then that's the minimum, technically, number of minutes that we need after we've calculated it all in order for all the oranges to rot. And then we just return max at the end. So I think this seems fairly reasonable. Let's go ahead and do a run on our code, and let's see where we end up. Interesting. Looks like we return -1. Let's see. Let's do a print on our row, or on our value, and then we'll do a print line here. Let's not do any of that first, and let's just see what it prints out as. Why is there? Why are there 6 values? Why? That is confusing. Why are there 6 of them? Oh no. It's just, yeah, okay. So 0, 100, 100. Interesting. Oh, I flipped these around. These should be, if the current value that it holds is greater than what we want to offer it, then we want to do that. So now this should be 0, 1, 2. Interesting. Matrix. This doesn't seem right. I mean, the cells are being printed correctly, that is true. Maybe Kotlin doesn't do a pass by reference natively. Pass by reference. Well, we can do a little bit of debugging here and say print line matrix at the end of this BFS. And then we can say matrix for each row for each value, print value, do that, this, and then print line. Let's see how the matrix looks like here after the first BFS. Huh. So it is passed by reference, but for some reason at front dot column, front dot row. So it should be propagating here and here. Let's see. We'll print that matrix at front dot column, front dot row. And source minutes. So it should start off as 0. Whoops. Should start off as 0, then 1 here. Interesting. Current cell is at front dot column, front dot row. Zero, 0. Oh, it looks like it's doing like a weird like loop. Yeah, it's never going beyond that. Interesting. Oh. Forgot to append front dot column to these. That's why. Because we aren't, in that case, we aren't propagating. We aren't propagating our rot properly. Okay, cool. Zero, 1, 2, 3. Interesting. Was there one of them that we missed? We did. Let's see, front. Okay, cool. Looks like that seemed to have worked for now. So, and we know that this is passed by reference, so we don't need that anymore. We might need this if we run into issues. Let's run all the test cases, and let's see where we end up. Let's just see if we pass these examples first. Okay, looks like we missed a print line there. I think that's all the print lines that we needed to take care of. Okay, cool. Let's toss in a submit and let's see where we end up. I'm guessing this additional traversal is probably going to screw me over in terms of runtime, but we'll see. Looks like it is slow. Let's see. What is something that we could do? Well, there's no way to really know if an orange will be rotten, right? Because if we hold a reference, we start off by saying 100, and it's lower, but it's not the max afterwards. Then that's a problem. Honestly, I'm stumped on as to this last part. Again, I feel like this last part is completely unnecessary to solving the problem. In order to find the max or the minimum number of minutes to rot everything. But I'm just not quite sure as to how sort of this Could I return something with BFS with replacement? Well, I could say that if matrix, like the max of here, so I could get the max of each rot. I can get the max of each rot sort of process. But that doesn't guarantee that all the oranges have been rotten, right? I still need a way to check to see if there are any oranges that will not get rotten. I'm not quite sure how that could be performed. That's a very, very good question. Again, I'm gonna put some thought into this maybe off camera, and I'll see if there's anything that I can think of.